Okay, so now we realize there are two triangles, so we got to solve them both. I personally like drawing both triangles separately. Okay, so I'm going to go to my next screen here. I'm going to draw the one triangle where this side came back towards me. So 51, 40, and 50. And then I'm going to draw the other triangle where this side went away. Still 51, 40, 50. Okay? This is where Miss Pettit does it a little bit differently. She kind of draws them both within the same triangle. So if she's teaching it or you're working with somebody in that class, they might do it slightly different. Okay? No, I'm very much of a separate thinker, okay? I want to focus on this one right now, and then I want to focus on this one, okay? That's just how I think, okay? Now, this 50, that was side C, right? So then this has to be angle C right here.
Yep.
This would be side B, and then this would be angle B up here. And then in this one, here's side C, here's angle B, here's side B. Okay. Pretty tough to solve for any of the B's, the side B or the angle B right now. Because you don't know either one of them. So what will you have to solve for first? Yeah? Angle C. Yeah, you're going to have to solve for angle C first. Okay? Doesn't matter which triangle you start on. Okay? Either way, your setup's going to be exactly the same. I'll show you. So what would I write to help me solve for angle C? Sine of 51 over 40 has to equal
the sine of C over 50.
Good, sine of C over 50. Using my law of sines, right? Oops, sine of C over 50. Sine of 51 over 40, so the sine of A over A. Remember this from 2 days ago?
Yeah.
Sine A over A equals sine B over B equals sine C over C. Okay? So sine of 51 over 40 would equal the sine of C over 50. Yep.
Don't we have to like the height line first to overcome each other, or is it just?
No, that's only when we're deriving the law of sines. The only time I drew that height in the other day was when I was showing you why the law of sines is true. Okay? And this one really, you'd have to draw your height way out here anyway, because it's kind of that obtuse triangle. Okay? Now, take a look at this, guys. Would your setup look any different right here? Wouldn't you have the exact same setup?
Yeah.
So when you go to your calculator, aren't you going to get the exact same answer?
Yeah.
Look at this angle C, look at that angle C. They're very different.
Yeah.
Okay. So, go ahead, do your cross products, tell me the answer your calculator gives you. Cross multiply. Again, if I'm doing this now, I'm getting good at this stuff, so I'm going to take 50 times the sine of 51. Then I'm going to divide that by 40. And then I'm going to have to do what to solve for C? Inverse sine of that answer.
Wait.
50 times sine 51. Divide by 40. And then you have to inverse sine that answer to figure out what C would equal. Because after you cross multiply and divide by 40, that's what the sine of C would equal.
No, wait, why do you want to inverse?
Well, if the sine of C is equal to this point whatever,
So then how do I just type that in?
previous answer. Use the previous answer key.
That's what I got.
You're probably right.
Is it what you
Okay.
got? What would you get?
50. 76.
Times.
76 point what?
2-7.
You
Okay.
want
76.27. Make sure you get that. 76.27. If not, make sure you say something.
So you rounded that. Yeah.
Well, I use 4 decimal places.
Don't use previous answer.
don't use previous answer.
No. She's saying she used 4 decimal places. I'm telling her don't. Use the whole previous answer button. You know where that is? Guys, there's a previous answer button. It's on the negative symbol on your graphing calculators. Okay? It says ANS. Use that. Don't use 3 decimals, 4 decimals, 5 decimals. Use the whole previous answer button. So therefore, because that obviously caused you to be off by 100th then, Tori, even using 4 places. So it's very important to use previous answer. So 76.27, yes? Okay, look at the angle C's in both pictures. Which one do you think is more realistically to be 76.27? The one over here. Okay? So then you're sitting here on this one saying, well, I do the exact same thing, my calculator's still going to give me 76.27. And yes, you're right. Okay? But it's not 76.27. It's bigger than that. Okay? It's actually 180 minus 76.27. And here's why. When you do inverse sine on your calculator, the calculator only gives you one answer, right? Take those problems that were on the test today at the bottom. How many answers were there on both of them? 2. So when your calculator gives you one answer, 76.27, it's because the calculator can't give you multiple answers. It's just not programmed that way. But there is another answer, okay? There is another angle whose sine value is 0.97142, okay? There is another angle. Now, how do you know what angle that is? Well, yes, you could just memorize 180 minus this one because that's what Mr. Alexander said, but let's make some sense out of it, okay? What's the sine of 30? 1/2. What angle in the second quadrant has the exact same value as the sine of 30?
120. No. 150.
Sine of 150. The sine of 30 and the sine of 150 have the exact same values, don't they? So if I said, what's the inverse sine of 1/2, your calculator is going to give you just 30 degrees. But isn't 150 also an answer to that? The inverse sine of 1/2 would also be 150 degrees. What do you notice about 30 and 150? What do they add up to? 180. Okay, maybe it's coincidence. Let's try a 60-degree angle. What's the inverse sine of root 3 over 2? Inverse sine of root 3 over 2. 60 degrees. Okay? The sine of a 60 is root 3 over 2, right? Well, isn't also the sine of 120 root 3 over 2? What do you notice about 60 and 120?
180.
Add up to 180. Okay?
That's so weird.
So your calculator, when you do inverse sine, your calculator is giving you the answer that's between 0 and 90 degrees. But there's another answer. It's in the second quadrant. So to get that other answer that's in the second quadrant, you just take 180 minus that answer on your calculator, and that'll give you angle C in this triangle. And anybody, what is that?
103.73.
103.73.
I know where I'm
Okay? So I kind of do work both problems together to start, but now I'm just going to strictly focus on this one here. That's 51. That's 103.73, so I can figure out angle B pretty easily because all 3 angles got to add up to 180, right?
Yeah.
Okay, little help there. 45.27.
Yeah.
That's rounded right now, okay? Now hold on here. This is where I get really picky, all right? On your calculator screen right now, it doesn't say 25.27, it says 25 point a whole bunch of decimal places, right? Okay? Make sure you use that answer now, that long decimal, when you go to set up your law of sines again to solve for side B. You follow me?
This is such a process.
So you're going to do sine of the 25.27 over B equals, and then I'd use the sine 51 over 40 again. So then, assuming you still had that 25.27, that long decimal on your calculator screen, I take 40 times the sine of my previous answer. So 40 times the sine of my previous answer, press enter, and then divide it by the sine of 51. Press enter. And what do you get for side B here? A lot of steps with the calculator. How am I doing on time on that?
You were at 11:14.
Anybody?
I like 21 point something. Cease to drag it out.
21.97. Is that right?
$21.97.
Yeah.
Okay. So there and there. Circle my answers so Mr. Alexander can find them in this mess. Okay? And you still got a triangle left over to do. Okay? Angle C is 76.27. Angle A was 51. Add those together, you get 127.27. So 52.73.
Sure.
And then again, set up the same deal, okay? Sine of 52.73 over B equals, again, I'd go sine of 51 over 40. And you're going to get, I'm going to cheat here. I think you're going to get about 40 point, book has it to one decimal place, about 40.9. Okay? Now go ahead and pause it for me.